Hello, welcome to the Republic Services Mine Hill Recycling Facility Tour. My name is Gabrielson. I'm the Operations Manager at the facility here in Mine Hill, and I'll be walking you through the tour of the facility virtually. We're located in Mine Hill, New Jersey, which is very much in the center of Morris County, as you can see here from the map. Our mission here at the facility is to process single-stream recycling from residences throughout Morris County, Sussex County, and Warren County. The bulk of the material that we handle is through the Morris County Municipal Utilities Authority. The single stream that comes to us every day is roughly 200 tons per day and is brought from the locations I mentioned. Please note the clean streets that you have on the way up to the facility. We take great pride in keeping the area around our facility very clean, and we actively send people down the hill to keep it clean and to keep our neighbors happy. The process for bringing material to us begins here at the scale. We record all the material types, origins, haulers, tonnages, etc. prior to unloading. As a truck moves off the scale, it drives past both of our processing buildings and turns right as it goes to unload in our tip floor area. Once on the tip floor, they're directed by two personnel, a gate attendant that we have, and a loader operator, and they operate the system in a safe manner to accommodate the level of traffic that we have. Oftentimes there are 2 or 3 trucks trying to unload at the same time. As you can imagine, they all finish their routes at roughly the same period of day, so we get a very busy period. And safety is the utmost importance in the unloading process. Here you see an MUA driver bringing his load of single stream, and in the background you can see our loader operator mixing up materials behind him. Material comes from the trucks and hits our tip floor, where it gets mixed into the main pile of single stream. To the right of this pile, we'll receive other materials such as commercial single stream, or straight loads of cardboard, rigid plastic, etc., that we can process differently than our main ingredient, which is, again, mixed single-stream material. At this point, you see the loader operator putting material into our in-feed, and you see a drum feeder breaking up the material so that it sorts better as it goes through our automation. The loader operator's main goal is to keep the material at a level that is consistent throughout the day to avoid too much or too little material going through the system at any given time. As you see here, there's a deep level of material going up an inclined belt to where it hits our first sort station, which is our manual pre-sort. This is a 6-person operation that works as a team to keep materials that are not supposed to be in the stream from going across our automation. That can include anything from gas cans to bicycles to packaging skids. We get everything that you could imagine would come from a household or even sometimes from a business. This belt goes faster than the one you saw previously, and the goal for this is to spread material out so the human eyes can see it and the human hands can grab it. The front people on the stream and the sort station break up material, look under things, and make more obvious to the next group of 2 that does the bulk of the actual sorting. You can see here materials they pull out: foil, plastic wrapping, trash, etc. Here's scrap metal, which is an item that we don't solicit, but we receive, as people think that metal cans are synonymous with scrap metal. We want metal cans in the facility that came from people's kitchens. Here's a shot of some of the material that we've taken off and put into our trash. It has no value to us in the stream. And here you can see them adding different pieces of contaminants. Next piece of sorting comes is our cardboard screen. We have screens that are both for cardboard and for paper. This is a cardboard screen, which is a series of shafts with discs which spin, pushing material uphill. The spaces in between allow 3D materials that are smaller in nature to fall between them and allow the cardboard to ride higher and higher and eventually go to a belt that carries them to a quality control station. The belt you see in front of you here on your left is the material that did not go up the screen for cardboard. It's going off to a paper sort. The material in the center right now never made it onto the cardboard screen and is going to go for a smaller sorting automation. And the material at center now is glass, which is heading into a glass cleanup system. At this point in the film, you see a glass crusher. This takes all the glass bottles that come into our system and breaks them into approximately a 1-inch squared piece. What you're looking at here is the end of our paper sorting line. That's our third paper screen, and that takes copy paper and smaller items and pulls them out of the container stream. In the ground behind you, you see our sorters working, pulling contaminants out of the paper. And that can be anything from cardboard to trash to plastic bottles or aluminum cans and various other items. Their job is to get the paper as marketable as possible after the sorting process has occurred. One of the things that we see a lot more in the stream in 2022 is an evolution to smaller fraction cardboard getting into the paper. This is done by direct-to-home sales through companies like Amazon and increased use of UPS and FedEx shipments. It's definitely changed the nature of the composition of mixed paper as opposed to how it began back in the early stages of single stream. Once sorted, materials go into a baler. And this belt here is another incline belt similar to the one that fed our pre-sort, but this feeds the baler. No, it's not single stream. This in this case is all cardboard. After dropping into a chute, it's compacted by 2 different rams and ejected. And we make a cardboard bale here in approximately 4.5 minutes. As you can see, we bale a lot of paper and cardboard in this facility. We also bale trash and rigid plastics. In the film in front of you, one of our forklift operators is loading a truck with paper bales. And there's the outside view of the truck. You can see a belt going overhead, which is a transfer belt, and I'll speak more about that as you see material here. This is the beginning of our transfer belt, and this carries commingled materials to our second building for processing. That's our commingled building, and here's a more direct view of that transfer belt. In a minute, you'll see our finished glass. Our glass is taken out of the cleanup system and dropped in a bunker where it's shipped off for remelt to make other glass materials. As it gets sorted, it's separated into different colors, amber, green, and clear, and can be recycled in that fashion infinitely. That's the material coming off, and as you can see, there's a lot of other pieces of material in there, small pieces of paper, etc. Our glass crusher system recognizes sizes. It doesn't recognize materials by their density or color or anything else. So anything that's about 1 inch squared can fall through our glass breaker. The film now goes into our commingled sort building. This building was installed and constructed in 2016. It includes automated sorts, optical infrared sort systems for PET and HDPE. It also has a belt magnet for tin and an eddy current magnet for aluminum. What you're looking at now is the incline belt that feeds our pre-sort. Material comes from across the building in our single stream into our commingled building here. It comes up an incline and is received at a 4-person quality control pre-sort. First 2 people in the pre-sort are handling paper. Their job is to remove as much paper from the system to increase the effectiveness of the automation downstream. Some of the items that we pick out that made it through automation in the first building come out here. Here's some of the metal that we pulled off that is not solicited. A big role that the pre-sort plays is removing flammable items from this stream at this point. They're very visible and they are very prevalent in the composition throughout America today. There's more flammables that we get. For the safety of us and for the quality of our product, we make that our number one priority in the sorting. As we move now into the automated sort in the building, you see a belt magnet running behind you. That extracts all the metals that come through the stream, be it tin cans with soup or tuna fish or items from the garage that aren't necessarily solicited, but the magnet picks them up and drops them all into this bunker. Each day we make about 5 bales of this metal. The belt in front of us here is bringing material to our HDPE sort. That's an infrared sorting unit, and now what you're seeing is the material that has been sorted. We'll get back to video of the HDPE being sorted in a moment. Material coming from HDPE goes into another optical sort, which you're going to see right here. This is our PET, number one plastic, and it takes the most voluminous plastic that goes through our stream and lends a very accurate, precise sort to it that human hands could not equal. And what you're seeing here is infrared cameras identifying plastic resins as PET, communicating with air jets, shooting them off of a belt. As they go up in the air, they clear a wall, and the items not hit by the air jet drop down. That completes the separation, and in a moment you'll see that from a profile view. So here you see PET rising above the wall and other items going below the wall. The bar rolling at your right encourages contaminants to go downward rather than upward. In this case, you see a mixture of PET dropping and PET going over. Quality control at the end of this sort, of the automated sort, helps to correct any differences or any variances in what happens in the automation. The view that we have here is quality control after we sort HDPE. We separate two different products here, HDPE colors and HDPE natural. The colors consist mostly of detergent bottles, etc. The natural consists mostly of milk bottles. As we pan in here, we're looking at another optical sort, and this is for the HDPE mentioned earlier. One of the major differences between the two different items that we sort optically are the size. The PET that we sort is very small, and the HDPE traditionally comes in larger formats due to what they hold: laundry detergent, milk, other items. You notice them going over the belt in less volume, but definitely in greater size. The automated sort in a facility is typically the most accurate, and for us, that is definitely the case. We process approximately 8 bales of this material a day, and probably another 15 to 18 of PET every day. So in a given week, we can make about 4 truckloads of material to go out as plastics. These resins are typically very valuable, and we're always looking for ways to improve the sort in this process. What you have now here is a slow motion view of it, where you can see items that don't go over and items that do go over. As this advances, I can bring up an item that is very important to us. And what you don't see here are the very small items that get through. Some of these are batteries, some of these involve a lot of chemicals. Flammables are always a very big issue in a facility. It's very important in educating the public that you remove anything that isn't required for recycling, to include small electronics in small rechargeable batteries. And boots. As we see this go through, we see the effectiveness of this sort technology. And as we've seen prior, we also have human hands touching the materials and ensuring their cleanliness. The process works very well here for us. Here's our pet quality control, and you see them taking off aluminum, other plastics, sometimes some trash items. They can sort well over 40 items a minute off of a belt in this station. In front of you here, you see also sharp needles, hypodermics that I mentioned earlier, small items that don't belong in our stream. Now in front of you is an eddy current magnet. Reverse polarity repels aluminum from the belt as it goes across. You see aluminum going over the wall, similar to what we did with an optical sort, and other items dropping down. Here's a different view of our pet quality control. In the background, you see quality control for our residue line, our number 5 plastics line, and for our aluminum. Beneath is a shot of finished product of HDPE colors. You can see the size of the materials that are pulled off, as mentioned previously. Every item that comes out of our system sits in a bunker as it awaits baling. If you see large shafts turning in the background, those pull material to the back of the bunker so they don't get jammed up and clogged up and accumulate right under our chute. They allow us to keep running continuously as materials accumulate. Here you see HD natural going to the baler. Our warehouse storage is a very important part of what we do in a facility, as we are dependent on the ports and other outlets for material. As they get busier and slower, we need to be able to work with them. So, finally, when a truck is done delivering, going back to where we started, they come down the hill, away from our tip floor, and they get weighed light, or empty, where their information is then completed. This information is communicated to their source, so they can keep record of everything that they need for purposes of DEP grants, invoice considerations, and other details. And that concludes our tour of the facility. I want to thank you very much for watching. Have a good day.